What's going on, guys? Welcome to another video with Mrs. Hill. Today I'm going to show you how to create and complete function tables based on an algebraic rule. We're also going to use the rule in the function table to graph ordered pairs. Take a look at this first example. In a game of What's My Rule, Kina picked the card shown at the right. Here's the card. Make a function table for 4 different input values and write an algebraic expression for the rule. Then state the domain and the range for the function. Okay, some of these things might look familiar and others are probably, some words in there we're going to talk about. You can see the rule is written here. The first thing you have to do is if the rule is given in words, you want to translate it to numbers and symbols. So we've got double a number. Double means to multiply by 2. So let's use 2n, double a number, then add 3. Then add 3. So here's the rule again. That's how you come up with it, okay? So we have written an algebraic expression for the rule, check. Now it says make a function table for 4 different input values. So I'm going to use 1, 2, 3, and 4. I'm going to apply the rule and find out the output. The input will be our x numbers, and the output will be our y numbers. In other words, when we put in 1 and we apply the rule, what comes out? All right? So I just picked these numbers for you. We're going to apply the rule, very simple. 2 times 1 would be 2, and 2 plus 3 would be 5. Look at the next one. 2 times 2 would be 4. 4 plus 3 would be 7. Very good. 3 times 2 is 6. 6 plus 3 is 9. You see how I'm applying the rule? Last one, 2 times 4 is 8. 8 plus 3 is 11. When you make your function tables, you don't have to have that middle column. This middle column is for showing your work. I'm going to show you an example on the next page. All I really need you to do is make a T-chart, put X and Y. If it says to pick your input values, then simply pick 1, 2, 3, 4 or 0, 1, 2, 3. Sometimes it will give you the numbers to put in, follow the rule, and you find the numbers to go out or the Y values. And so this would be sufficient for me. You do not have to have this middle column showing all the work, okay? There's one more thing here that probably looks unfamiliar to you. And that's this right here. State the domain and the range. All the problems I'm going to assign are going to ask you the same thing. State the domain, state the range. Here's the definition for you. You write this down. Domain is simply the x values in a function. So domain is the x numbers. The x numbers or the x values. Range. The range is the y values. The y values in a function. Okay? And so when it's asking you to state the domain and state the range, you're simply going to, you can use D for domain, list the domain, 1, 2, 3, 4. These were the numbers we picked for the input. And then we're going to state the range. The range numbers are 5, 7, 9, 11. What did we get out when we applied the rule? 5, 7, 9, and 11. Okay, that's it. We just used a rule to complete a function table. This is something we need to be able to do. Use a rule to complete a function table, and sometimes you're going to need to figure out a rule based on a verbal expression, verbal words. Okay, now I want you to try one. Make a function table for 4 different input values and write an algebraic expression for the rule. Then state the domain and range of the function. Here's the rule. Double a number and subtract 1. So I'm asking you to do 3 things right now. Number 1, I would write the rule first. Write an algebraic expression. That should be step 1. Step 2 should be to make your function table with 4 different input values. You can use whatever you want. 0, 1, 2, 3, 1, 2, 3, 4. You can use bigger numbers if you want. And then number 3, state the domain and the range. List the domain and the range. Just make a little list. Pause the video. Try this. Unpause when you finish and we'll go over it. All right, let's try to follow the steps I suggested you follow here. So step 1, how did you translate these words into numbers and symbols? Double a number, that means 2 times a number, and then subtract 1. That's the rule. Now, second thing is we have to make a table. 4 different input values, okay? So X, Y, I'm going to use 1, 2, 3, 4 again. Now, if you use different numbers, you're going to have different output values, and that's okay. This is just an example. Hopefully you use 1 and 2. Those are easy ones. All right, now I'm just going to apply the rule. So 2 times 1 is 2. 2 minus 1 is 1. This would be the output if you picked 1 for an input. Okay, now I'm going to use 2. 2 times 2 is 4. 4 minus 1 is 3. So if I put in 2, I'm going to get out 3. 3. Okay, 2 times 3 is 6. 6 minus 1 is 5. And last one, 4. If I put in 4 here for n, 2 times 4 is 8. 8 minus 1 is 7. Okay, the last thing, and this is just like the problems I'm going to assign to you. Last thing is you're going to list your domain, which is, in my case, I picked 1, 2, 3, and 4. And my range in this scenario is 1, 3, 5, and 7. Okay? Sometimes they will give you specific numbers that you have to use. In this case, they didn't, so answers may vary. Let's try one more. An assembly line produces 30 boxes per hour. Write an equation to find the amount of boxes it can produce for any number of hours. Make a function table for 5, 10, 15, and 20 hours of production. Then graph. Okay, I'm going to do this one with you, but I'd like you to write it down. So the first thing I have to do is write an equation, not an expression, to find the amount of boxes it can produce for any number of hours. Okay, so it tells me up here that I can make 30 boxes per hour. Hopefully that keyword per is popping out at you, and that means time. So I can use the equation n equals 30h. Now I use n and h. You can use any variables you want. You could use n is the number of boxes. You could use b. So the number of boxes, I could say b equals 30 times the number of hours. 30 boxes an hour will give me the total number of boxes. The variables aren't as important as making sure you have the right rule. Now I'm going to make a function table, but this time they want me to use specific numbers. So it says hours, so this is my each, and I'm going to use 5, 10, 15, and 20. Now I'm going to apply this, and I'm going to apply this rule and multiply by 30. Okay, and this is going to give me the total number of boxes. So 5 times 30 is 150. 10 times 30 will give me 300. 15 times 30, you can work these out if you want, is 450. And 20 times 30 will give me 600. Okay? The last thing it's going to ask you to do from time to time is to graph these on a coordinate graph. And I'm going to show you how to do that in class tomorrow. It's pretty simple. This would be your X, this would be your Y. But I'm going to show you how to come up with a scale for these numbers because they're not always going to be easy counting by one type numbers. For now, make sure you know how to make and use a function table based on a rule. Okay? All right, I hope you bring all those notes to class. We'll practice this again tomorrow. See you then.